5 things everyone should know about ancient oceans. Number 2. 34 million years ago, the Earth transformed from a greenhouse into an icehouse.
The EOT is the Eocene-Oligocene transition, and it refers to an interval of time around 34 million years ago when the Earth transitioned from a greenhouse world into an icehouse world. And it's the first point at which we think that we started to develop these really big continental scale ice sheets on Antarctica. There probably wasn't any ice in the Northern Hemisphere at this time, so we're really just talking about ice in the South Pole. The long-term decrease in global temperatures that occurred during the Eocene, that was part of these long-term geological cycling. So, for example, increases in silicate weathering. Silicate weathering is the process by which you break down rocks and it sucks down CO2. Because CO2 is a greenhouse gas, as soon as you suck that CO2 down, it's going to reduce the global temperatures. And also at this time we had things like the Himalayas were developing, so the collision of India and Asia. And as soon as you start sticking the Himalayas up into the atmosphere, you massively increase your weathering rates. Why exactly at that point, 34 million years ago, that we built the ice sheets? Well, the first thing is the continents were in the right place. Antarctica was right over the southern pole, the ideal place to build an ice sheet. The background temperature was in a sort of suitable place. It was cool enough that you could start to get snow precipitating at high latitudes. And also we eventually reached a point where the position of the Earth in relation to its cycle around the sun meant that we didn't just have colder winters where snow could be deposited, but we had colder summers. And that's really important to building ice sheets because you need the cold summers to make sure your ice doesn't disappear. And this was caused by something called obliquity, where the tilt of the Earth changes over a 40,000 year cycle. The tilt of the Earth was much lower, and that meant the difference in average temperatures between the tropics and the poles was far less, and also between winter and summer. So the ice that was building was able to stay. The ice caps on Antarctica, they first of all started to develop on small, high, isolated regions, mountainous areas. And it was only through time that eventually those small ice caps coalesced into a much larger continental size ice sheet. And as soon as you get that coalescence, it's so hard to get rid of the ice sheet. And that's from that point onwards, 34 million years ago, we pretty much have had ice on Antarctica.